Yeah, so a very good morning to all of you. So today we'll be discussing about the whatever given in your homework that was regarding the delay calculation by using 8-bit registers. Okay, and in this kind of registers we have seen that these three examples, I mean these three sums were there. Okay, so you can generate any kind of delay by using these registers. Okay, so firstly we'll come to the first one. So from yesterday, anybody has done any extra thing like Rishabh Kumar, have you done the second one? I mean this one.
Sir, I am tried but didn't get the
Rishabh
right.
Kumar, are you there?
Hello.
So
Hello.
yeah, yeah. Tell me, Rishabh.
Sir, I didn't try.
Okay. So Rani Rupam is not there. Okay. Okay. So we'll be slowly doing this. Okay. So I'm repeating once again how to calculate the delay because this is a very important thing in your syllabus. So firstly, we'll be doing the second example, just like this one. Okay. So look in the copy that firstly move R0 hash 255H. Sorry, 255 only. So this is the decimal number. Move R1 comma hash 200. That is also a decimal number. DJNZ R1 here. It will be coming here. Okay. And DJNZ R0 here 1. Okay, so it will be coming over here on only. Okay, so this is the program. Okay, so just a minute. Okay, so here firstly we'll be doing this particular loop. Okay, this particular loop. Okay, so here the machine cycle is 2, the here machine cycle is 1, here machine cycle is 1, here machine cycle is 2. Okay, so here 200 immediate data has been loaded to R1. Okay, so for this, how many times this loop will be rotated? This 200, let us write like machine cycles for here loop. Okay, so this will be 200 into 2 plus 1. So this will coming like 401 machine cycles. Okay, now machine cycles for here one loop. What is this?
Sir, 255 into 2 plus 1.
Yes. So 255, okay, into 401, okay. Is this true? Into 2, understood or not? Understood or not? Plus for this will be 1. Understood or not?
Sir, machine cycle for here loop will to this one 255.
Sorry.
The machine cycle of here loop will be multiplied to 255. 401, that one.
Why?
So you have written 205 into 401.
205. Where? Yes.
Sir,
For
255. Sorry, sir, 255 into 401.
right.
So why 401 is multiplied here?
Because this loop will be rotated how many times? 255 times,
Yes, sir.
right? Because by executing this one at the first iteration, this will come here, then it will rotate 200 times, okay? Then it will come out of the loop, then again decrement this content by 1, 254, then again go here. So again, this 254, I mean, whenever the content of this R0 register is 254, then again this loop will rotate 200 times, and this will be repeated up to 255 times. So this 400 machine cycles will be repeated 255 times.
Yes, sir, understood.
Okay, and as this is the cycles are there, so multiplied by 2. So this will be the answer, total machine cycles. So it will come like what, 401?
So 204511.
Okay, 204511 machine cycles. Okay. So if the crystal oscillator frequency is 12 megahertz, okay, then the delay will be 204511 into 12 by 12 megahertz. Okay, so it will be coming like 204511 microseconds, okay, or 204.511 milliseconds. Okay, understood?
Yes,
Yes.
sir.
Yes, sir.
Okay. So the same way, because we'll not invest much time on this, is try yourself in your home. Okay, so I'm going forward. Just see, this is the example. Find the size of the delay in the following program if the crystal frequency is 11.0592. Clear? So now you can see that move A, look at the program first. Be careful, okay? Move A, that is here. This is the immediate data 55H has been loaded to a register, and this has been fed to port 1. Okay. Now A call delay. A call delay. This is the thing you can see. This is a very interesting program. Just port 1. Think about the port 1. So port 1 is having 8 pins. Okay. So 8 pins. Now 3, 4, 5, 6, 7, 8. So 8 pins are there. So with the 8 pins, if we connect LED, Okay. For every pins, we are connecting an LED. Okay. Now suppose this is P1.0, P1.1, P1.2, and so on to P1.7. Okay. Now just see move A comma 55H. That means if we convert it to its binary number, then it will come like this one 55H, right or wrong? Right, because this is the 55H. If we convert 55H to its equivalent binary number, then it will come like 0101 0101H. Clear? So in this, if we fed this to this particular port 1, just look into the second program, I mean second line of the program, just see that this will be 0 1 0 1 0 1 0 1. That means this one LED will glow and 0 LED will be off, will not glow. Clear? And then a call delay is there. Then again complement A. That complement A means zeros will be 1, 1 will be 0. That means before just before this CPLA complement A operation, whatever the LEDs was glowing, those will be turned off, and which LEDs was not glowing, then they will be turned on. Clear? So just see what is the purpose of the delay here, because the purpose of the delay is to turn on or turn off a particular LED for a certain time. Clear? So you need to calculate the time. Okay. So here the delay program is there. Okay. So what is the delay? What will be the delay? Now delay program is here. So have you understood the program, or I need to, is it clear? Is it clear or not?
Sir, can you please repeat the LED part?
Look into the program first. Okay. I'm removing everything. This 55H. Okay. This 55H is loaded to A register. So 55H, that means this 55H is an 8-bit data. So 8-bit data is loaded to A register, and this 55H data, if it is converted to its binary form, so it will come like this 0101 0101. Okay. And in the next instruction, you can see move P1 comma A. That means the content of A register that will be moved to the port 1. Okay. And port 1 is also an 8-bit register. Okay. So the content of this particular A, that is fed to, now let me very clear, that content of A register that will be fed to port 1. That means it will be 0101, sorry, 0101, like this. So whenever it is going 1, this LED will glow, and whenever it is 0, then no LED will glow. Right. So now look into the program, that some delay program is there called delay. Okay. So delay program is there because this LEDs needs to be glown for a certain time, for a short amount of time, because otherwise our eyes are not capable of capturing those high frequencies. Okay. If the LED glows very frequently, turned on and turned off, then we cannot see that whether it is turned on or it is turned off. Okay. We cannot track the changes. So that some delay needs to be generated so that the LED can glow for a certain time, and it will be turned off for a certain time. Clear? And in the next instruction, CPLA, that means complement the content of A. That means the complement the content of port 1, 2, because in the next instruction again, it will be going back to here. Okay. So again, the content of A register will be moved to the P1. So after complement, this will be 1 0 1 0 1 0 1 0. So whatever the LEDs were turned off, they will be turned on, and the LED turned on, that will be turned off. Okay, and wait for some time. So the LED will glow for some time, and the LED will be turned off for some time. Clear? Clear now, Rajkumar?
Yes, sir.
Okay. So coming to the delay, the DJNZ R3 here. This is the here loop. So what will be the delay? You need to calculate this one. Okay. So what will be the delay? Calculate and tell me.
So 401 microsecond.
Okay. So how can we do? That is 200 into 2 plus 1. Okay. So this will be coming like machine cycles. So 401 machine cycles. So delay will be 401 into 12 divided by 11.0592 megahertz. Okay, because in the question it is mentioned that the frequency is 11.0592, and this will come like 401 into 1.085 microseconds. Okay, so it will be coming like how much? 400
So 435.11.
oh, sorry, 435, right? 435.11 microseconds. Okay. So for this time, this LED will glow, and for the same time, the LED will be turned off. Okay. And this thing goes on unless we stop the program. Understood or not? Okay. Now in the lower part, you can see, you may ask that sir, there is the answer is not matching with us. Why? Because in the delay program, there is return is there, because whenever we are using some delay program, after the execution of the delay, it is very necessary to get back into the main program. Okay. So by executing this return, this will go back to this particular instruction, this CPLA. Okay. Now you can see in the calculation, one more machine cycle was added for this return instruction. Okay. So be careful while while calculating this kind of programs. Okay. Okay. So we are going forward. So just write this. Okay. Now here we can see that move R0, move R2, 200 and move R3, 250. So these two registers has been used for the calculation of delay, and NOP, that is no operations. Again NOP, that is no operations, and two loops are there, DJ and Z loops. I mean, sorry, DJ and Z instructions, and here and again these two loops are there and return. Okay, so again this is the subroutine program, and this delay program is stored into some other memory location. We will see in the practical also that how this particular instructions, I mean this particular delay program can be executed. So here you can see the calculation for the here loop 4 into 250. Now why 4 into 250? Because, just a minute, because for here loop, okay, so for here loop this is 1, for this NOP, for this NOP again 1, and for this 2. So this together forms 4 into 250 means R3 is loaded by 250. Okay, and the delay is this much. Okay, 1085 microseconds. Okay, now the again loop repeats for the here loop 200 times, as we have discussed in the second example just today in the first half. So therefore 200 into this particular delay, this will be the total delay that is generated by the again loop. Okay, and particularly the result comes like this particular milliseconds. Okay, understood? So just you calculate on your own so that you will be ready to understand. So so we'll be doing some particular programs. Okay, just a minute. Okay, so we are there for just write the question, that write a program to get the x value from P1 and send x square to P2, sorry, P2 continuously. Okay, understood or understood the program or not? That means x value means any value. Okay, whatever the value is. So write a program to get the x value from P1 port 1 and send x square to P2. That means if we get the value of 5 from P1, then the objective of the program is to send 25, that is 5 square, to port 2. Clear? Clear or not? Clear or any question? Understood or not?
Sir, repeat.
Anyone? Any
Sir, repeat, sir.
Sir, repeat, sir.
write a program to get the x value from P1. That means if we our objective of the program is, if we get the value of 4 from P1 port 1, then send the 4 square, that is how much? 4 square means
16.
then send 16 to P2. Okay, this is our objective. That means we need to calculate the square, or the I mean square of any number. Clear? Okay, so is this clear? Is the objective is clear?
Yes, sir.
Yes, sir.
Okay, so look at the program. we are doing in paper. Just first, we'll be doing like WordG 0000H, so that we can start writing the program. Okay, start writing the program from 0000H. Okay, so firstly, we'll be loading the DPTR. Okay, so DPTR is the only register, only 16-bit register that is present in the microcontroller 8051. Okay, so we'll be doing like this. Okay, now why this 0300 has been written? We are coming back to this question, why? Okay, so before this, again this particular A register, this is to be loaded by FFH. Why this 0 is there? Because whenever you are writing some assembly language programming in simulator, then the simulator will not understand this particular character. I mean, this particular this is the letter. Okay, and if we use without this 0, then the assembler will get, I mean, give an error. Okay, so this is the I mean, structure of or the whatever the compiler specifications that has been given in the 8051 microcontroller. Okay, so this 0ff is there, and move p1 comma p1 comma a. Now this ff means all one, that means the content of the A register, that will be 11111111. Okay, all one. Now why this is given? Because by default this P0 is output port. Okay, but as the question is there, as the problem is there, get the X value from P1. That means from P1 some external data is coming. So P1 needs to be an input port, है ना? P1 से कुछ डेटा माइक्रोकंट्रोलर के अंदर आ रहा है. That means P1 should be an input port. ठीक है? That is P1 and P2. Okay? So P1 से हम लोग डेटा लेंगे और P1 से P2 से डेटा सेंड करेंगे. Clear? So P1 is input and P2 is output. Clear? So P1 को input port के हिसाब से कॉन्फ़िगर करने के लिए we need to give all ones to the P1. So the first, this A register will be loaded by FFH, this one, and this FFH is sent to this port 1 to make this as input port. Clear? Now move C A comma @ A plus DPTR. Okay, sorry, just before this, just a minute. Move A comma P1. Okay, अब देखो ये P1 comma A, this is done for configuration of the port. Don't get confused. This P1 comma A, that means all ones was said P1 because we need to configure this particular port 1. Clear? But in this case, this move A comma P1, we need to get the input from P1. Okay, so whatever the input is coming through this particular port 1, this needs to be stored into another 8-bit register, that is nothing but A register. Okay, now suppose, now here, for example, we are sending 5. Okay, suppose 5, for example. So this 5 has been loaded to this A register. Clear? Now move A comma at the rate A plus dptr. Now I'll tell that what is the function of the dptr here. Okay. Now if we suppose we are taking a table, okay, that is formed prior to writing the program. Okay, so let us think that from 0300H 00 is loaded, 0301 01 is loaded, 0302 04 is loaded, 0303 09 is loaded, all in hex. Okay, all in hex. 0304H 16H not H, 16 decimal, 0305H 25 decimal. We are not writing H here, so by default it is showing that this is the decimal number. Okay, 0307H 49, 0308H 64, 0309 91. Okay, sorry, 81. Okay, so if we don't write hex, then also it doesn't change any meaning. Okay, so this is the table. We have already made this before writing this particular program. Okay, so this is called lookup table. Okay, from the table, from where we can trace the stored data. Okay, we have made this table, we have calculated manually that each square of this particular data, okay, that means 0 square is 0, 1 square is 1, 2 square 4, 3 square 9, 4 square 16, like this. 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81. We have made these calculations and we have made this table. Clear? Just a minute. Yeah. So now A will hold the value. We are getting the value of 5. So A will hold the value of 5. dptr is having the value of 0300. So what will be A plus dptr? A plus dptr will be 0300H, that is the value of the dptr, and A will hold the value of 5, that is 0305H Yes, so this 0305H, now 0305H is having the value of 25. Okay, so 0305H, that is 25, that has been loaded to, that means A plus dptr is 0305H. So at the rate A plus dptr, that means the memory location, the data stored into the memory location, that is 25. This 25 is loaded to move A comma at the rate A plus dptr, that means A register. Clear? So Understood or not? And this particular A will hold the value of 25, and this particular register value will be stored into port 2. Now our objective is solved. Okay, so here we can see this will be going on and on, because one time we'll get 5, another time we'll get 6, another time we'll get 2, and so on. Okay, so which step will be there here? Okay, okay, so you can take a snapshot of this particular slide so that you can practice on your own, because in the next class I'll be discussing about the I'll be giving some sums to solve. I'll give some programs to solve. Okay. Okay, now I'll share this one. Just record your attendance, and after the recording of attendance, you may leave the class.